A little impromptu video just to help teachers during the revision period. I plan for the month of May to go through lots of different ideas here to reduce workload and increase your impact. So sharing lots of my Mark Plan Teacher 1-minute summaries with you over the month ahead. But this short video, I want to just share some of the things that I've been researching for my guide to memory research. So I'm having a lot of schools and teachers ask me for help with how we learn, the memory part of what we do in our classrooms. So here's a 1-minute summary of the research that I've put together in my latest book. This screenshot here coming through. Let me just swap those slides. Oops, went a bit too far. So those are the kind of headlines from, just touching the tip of the surface, I suppose. An overview of brain history and the evolution of cognitive neuroscience, cognitive psychology, and the world of cognitive science, which many teachers are interested in. But this is what I want to talk to you about literally in a couple of minutes. So bear with me. I want to talk to you about how memory is formed anatomically. Now, I'm not an expert, but I've been spending several years digging into this in closer detail. So let me just go through one step at a time. Approximately, depending on how many glasses of wine you have, the adult brain's got 86 billion neurons, give or take one or two. I believe that's the equivalent of the number of stars in our galaxy. So for context here, if you count to 1 million, it'd take you 11 and a half days. If you count to 1 billion, not that we'd have any time to be able to do this, it'd take you 31 years. So just to try and get a kind of sense of what 1 billion looks like, we have 86 billion neurons. Our neurons look like this. So we've seen this in some of our biology lessons at school or in adults when we do our final reading, further reading, I should say. But anatomically, when we form a new connection, so either you're watching this for the first time, if you revisit the material, you'll strengthen your connection, so you form a neural connection. Some of this is familiar to you and you're retrieving it, then we're exploring your long-term memory. Things I say elicit connections in your schema, and this is how we bring knowledge together and form new connections. So we've got all these kind of technical parts: dendrites, nucleus, the myelin sheath, and so on and so forth. Dendrites are those where the impulses are received from your so from the chemical signals. Met a few biology teachers on my travels as a result of sharing this. The myelin sheath, the stronger this is, the fatty substance along the axon shaft allows the transmitters to travel more reliably. And I'm very conscious of the language that I might use here in case I'm technically not 100% accurate. So I share this with disclaimers and a bit of caution. I'm just a teacher interested in how we learn. I've explored a bit of brain history, the anatomy of the brain, and trying to see how I can shape the way that I teach even better. Our axons, so these axon hillocks, they carry the signals away to different to other neurons, to other dendrites. So they kind of, I'm going to say, tickle together. That's not a very technical word. So the endings make synaptic connections. Now, if I move over to another graphic shortly, you'll see they don't actually connect. There is a kind of transmitter of information between two neurons. So that, if we put a microscope over, they form what's called a synaptic cleft, it's a bit like a charge over a magnet. So the myelin sheath, as I mentioned, most of it happens before birth, which is why I really believe, having spent my whole life as a secondary classroom teacher, that early years is the most critical part of our education process. Shouldn't take me 30 years to work that one out, but it has. And actually, I look at all our young children in our nurseries and how we could do a bit more here to help shape those critical parts of myelination formation, I suppose. So a fatty substance insulating the axon to stop the signal from degrading. Our synapses, so these are the actual connections. I didn't know the word synapsis derives from the Greek language to form a connection, so there you might have learned something new. Neuroplasticity, so the stronger the connection, the stronger the signal, etc. So this is what neuroplasticity is. And then here's the little graphic I've got for you here. So that kind of floating between two physical neurons, there's this gap in the middle where the charge connects to one another. So if you think about two connected neurons, so if I go back to, how long does it take you to count to 1 billion? If you retain this information, when we think about it as an analogy, if we walk through a woodland when a path might be challenging, that kind of well-trodden path versus going over some new vegetation, when we walk over it time and time again, then the path starts to form, and that's how we can retrieve information regularly, or we can go through the path once again and then form even further connections. So think the next time you go on your dog walk, if you go off the well-trodden path to a new path, the more times you create that connection, the more familiar you become with this new route. So that's how we elicit further schema. So, think tomato ketchup. You all know what tomato ketchup is. You've tasted it. You can describe it. You can elicit further information. So red tomatoes, all sorts of things. But if you have no schema, corpus linguistics, whatever it might be, if you have nothing to draw upon, we really need to get back to the foundations of how we form this knowledge in the first place. Anyway, I think that's enough for now. There's lots more of this to come, but I just thought I'd do a little impromptu video, as ever, sharing some ideas from Guide to Memory. So there's lots more in there. Get in touch if you need any help. And I'm also going to start to share loads of little workload snippets to help people in Mark Plan Teach. If you need any help, you know where I am. I hope you're well, and bye for now.